All right, guys, we're going to cover section 12.3 today. Yesterday we did surface area of prisms and cylinders. Today we're going to do pyramids and cones, so a little different shape. So we should be comfortable with what we did yesterday. So find lateral area of the surface area of pyramids. So again, laterals around the lateral edges. So with a pyramid, those are triangles. And for a cone, it's not really a shape in particular, it's that flat surface going around, or smooth surface going around. So we're gonna get some formulas for that. Again, I recommend that you have a place in your notes for a pyramid and a cone, and that you write the formulas down that we get. You know, we're gonna start with surface area, we'll move our way into volume as we go. So a regular pyramid is a pyramid that has a base that's a regular polygon, okay? So a square, regular pentagon, something like that, okay? The slant height, when you look at the triangles that are on the side of a pyramid, the height of the triangle comes down at an angle, and so that slant height is the height of the triangle. A right cone simply means that the altitude is perpendicular to the base like that, whereas an oblique cone is just, you know, turned a little bit at an angle. So there's what a pyramid looks like. This one appears to have a square for a base. The formula for the lateral area is 1/2. Again, capital P is the perimeter of the base, and L is the slant height. So if you look at the picture, L is that height of that triangle, so it comes down at an angle, okay? The actual height of the pyramid goes from the vertex at the top there straight down perpendicular to the base. That slant height is just the height of that triangle. So, if we're asked to find the lateral area of the pyramid, remember, our formula, 1/2 PL, and since it's a square pyramid, the base is a square, so the perimeter is going to be 2.5 times 4, or 10. The slant height they've given us is 5, so we're just going to plug those numbers in and get a result, okay? Not so bad. Why don't you guys try one? All right, so our lateral area is 1/2 PL, okay? We have a square pyramid, so the base is a square, so the perimeter of the base is 4 times 4, or 16. And the slant height they've given us, that's 8. Okay, well, 1/2 of 16 is 8, 8 times 8 is 64, so it looks like B is our answer for this one. Okay. The entire surface area is pretty similar, right? It's the lateral area around the outside plus the base. You got to include the base. So this capital B is the area of the base. Again, now we got to lean on what we learned in chapter 11. What formulas do we have for regular pentagon or a triangle or a square or whatever we're dealing with? So make sure you have those formulas at hand as well. So what about this one? The surface area of the pyramid. So what do I need? 1/2 PL, so I need the perimeter of the base, which I can do, 8 times 4. I need the slant height. Well, the slant height is not given to us here. I'm given the height of the pyramid, that's 6, and this, you know, I'm able to make a right triangle, but it looks like I need the Pythagorean theorem to help me find that slant height. And then the area of the base, well, I know that, 8 times 8, I can figure that out quite easily, but in order to find this slant height, I'm going to need to go 4 squared plus 6 squared equals L squared, okay? And I think we're going to see this on the next page here. Okay, so 6 squared plus 4 squared is 52. So the slant height's the square root of 52. The rest of the stuff I can calculate pretty easily. So perimeter, 4 times 8. Area of the base was 8 times 8. So now I can plug in stuff. We said the perimeter was 32. Slant height was the square root of 52, and the area of the base was 8 times 8, or 64. Now I just need to plug all this into the calculator and see what I get. About 179.4. Okay? So, why don't you guys give this one a shot? We'll work through it together here. Okay, so surface area is going to be 1/2 PL plus B. So we're going to go through, we're going to try to calculate the individual parts as we go. The tough one here is that slant height, right? If this whole side is 6, then this distance inside of here is going to be 1/2 of that, or 3. So I'm going to be able to say that 3 squared plus 8 squared equals L squared for my slant height. Okay, so 9 plus 64, what is that, 73? Take the square root. And for now, we'll just say that the slant height's the square root of 63, or 73, sorry. Okay? The perimeter of the base, well, that's not so bad. You've got, each side is 6, and there's 4 sides. 6 times 4 is 24. Okay? And the area of the base, or capital B, is 6 times 6, because you've got a square, so that's going to be 36. Now I've got everything I need, so I'm going to come over here, and I'm going to go 1/2 times P, which we said was 24, times L, which we said was the square root of 73, plus the area of the base, which we said was 36. Now I just need to put that into my calculator. So 0.5 times 24 times the square root of 73 plus 36. I get like 138.5. So it looks like C is our answer here. So be real diligent, guys. Find the individual parts first, boom, 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 and then plug them back into the formula, okay? So find the surface area of the regular pyramid. So this, look, if you look at it, it's a regular hexagon for the base. Okay, how do I find the area of regular hexagon, you guys? So when I'm doing the capital B thing, they give me the slant height and they give me a side, so I can find the perimeter of the base. I have the slant height, but the area of the base is that 1/2 apothem times perimeter. So I'm going to kind of draw a portion of my hexagon off to the side, and I got to find the central angle and some of those things that we were doing back in chapter 11. So let's kind of do that here. So the perimeter of the base, easy enough, right? 10.4 times 6, because you've got 6 sides. But now the length of the apothem. So the central angle, if you were to draw in one of these triangles, would be 360 divided by 6, because there's 6 sides. That'd be 60 degrees. When we drop the apothem down, that cuts it in half. So that's a 30-degree angle up there. And to find the apothem, okay, the other thing I want to point out here is, remember this side was 10.4, but the apothem cut that in half. So that's only 5.2, that little triangle that we're looking at there. Excuse me. So now I got to say, well, what kind of trig can I use to help me out? So compared to the 30, 5.2 is opposite, the apothem is adjacent, opposite over adjacent is tangent. So we're going to say the tangent of 30 is 5.2 over A. And so when the variable's on the bottom like that, we divide. So we're going to take 5.2 divided by the tangent of 30 and get an approximation for A. So now I've got the apothem, and when I calculate the area of the base, I'm going to go 1/2 apothem times perimeter, okay? And we already knew what the perimeter of the base was. We had calculated that 10.4 times 6. And then the apothem's 9. So now I've got the area of the base, that 290.8. I can put that in my back pocket and then take a look at the formula for surface area here, okay? So that number that we just calculated goes in for B. Perimeter we said was 62.4. They gave us the slant height. There was the area of the base. I can put it all together now to get that 748.8. Okay, why don't you guys try one? Same kind of thing. It looks like we've got a hexagon for a base. So I'm going to write the formula up here. Surface area is equal to 1/2 PL plus B. And then I'm going to do some work kind of off to the side here. So let's take a look at that hexagon for a second. So if I put one side down here, 360 divided by 6 again is 30, just like we saw on the previous screen. So this right here is a 30-degree angle. And if this was 6, this gets cut in half, so that's 3. So if I want to find my apothem, I'm going to say that the tangent at 30 is equal to opposite, which is 3, over adjacent, which is A. And again, the variable's on the bottom, so I need to divide, okay? I'm going to take 3 divided by the tangent at 30. And I'm going to get about 5.2. Okay? Now this is going to help me calculate my base, right? So let's calculate the perimeter of the base. Okay? Well, there's 6 inches on the side. There's 6 sides. 6 times 6 is 36. So that means the area of the base, 1/2 apothem times perimeter. The apothem we just said was that 5.2, and the perimeter we said was 36. Okay, so let's work that out. 0.5 times that 5.2 times 36, I get about 93.5. Well, now I'm going to come back up here and I'm going to start putting numbers into what we know. So, perimeter of the base we said was 36. The slant height they've give us here, that's 9. And then the area of the base, 93 and a half. Okay, well now I have to type all of that into the calculator. So 0.5 times 36 times 9 and then plus that 93 and a half. I get like 255.5. Okay, but again, you notice how I broke it down one little part at a time. Let's find the area of the base, which means I need to break it down, find the apothem and the perimeter. Let's find perimeter of the base, the slant height, and then I can put it all back into the formula. Okay, so take your time on these. Okay, lateral area and surface area of a cone. A cone is really like a pyramid, but it's just got a circle for a base. So when I say 1/2 PL, well, P becomes the circumference, right? 2 pi r. Well, half of that is only pi r. So pi RL is your lateral area. And so that's that surface going around this way. And then the area of the base is just a circle, so pi r squared. So pi RL plus pi r squared. So the two things I need are the radius and the slant height. If I have those two things, I can find both the lateral area and the surface area of a cone. So a sugar cone has an altitude of 8 inches. Now that is the height, that's not the slant height. That's going from the vertex straight down. In a diameter of 2.5 inches, find the lateral area of the sugar cone. So let's just sketch this thing really quick here. Okay. Pretend I'm good at sketching these. Okay. So the diameter is 2.5, which means the radius is going to be 1.25. Okay. And I'm going to put this up here. This is that 8. This is that altitude of 8. And so my slant height's going to be there. So I've got the radius, which is part of the formula, but I don't have the slant height. I'm going to need the Pythagorean theorem one more time here, aren't I? Okay. So we're going to see that they're going to work through that. This is just reminding us that the radius is 1.25. Okay. So Pythagorean theorem, 8 squared plus that 1.25 squared to find the slant height. So now we get about 8.1 for the slant height. We already have the radius of 1.25, and so we can put it into our formula, right? So there's the lateral area, pi RL. Replace R and L with what you got. There you go, 31.8. Okay? All right, why don't you guys try one here? Okay, a conical birthday hat has an altitude of 6 inches and a diameter of 4. So I'm going to sketch this for you. Okay, so a diameter of 4 means our radius is 2, and altitude, whoops, our altitude was 6 there. Sorry, it's probably going to erase more things than I wanted to. Okay, our altitude was 6. And so our slant height here, we're going to say that 2 squared plus 6 squared equals L squared. Okay, well, 36 plus 4 is 40. Take the square root, so L is going to be the square root of 40. Lateral area is pi RL. Okay, well, that's going to be pi times the radius, which was 2, times our L, which we said was the square root of 40. Now I need to put it into the calculator. So pi times 2 times square root of 40. I'm getting 39.7. Okay, so sometimes a sketch is helpful to see where that right triangle is going to show up so that you can calculate it a little bit easier. Okay, so there's your assignment, guys. Page 859, 7 to 29 the odds. Good luck.